Hello everyone, this is Dr. Maha Abdurrahman. Today I will complement my last week video about ionic bonding with the properties of ionic compounds. So I really urge you to have a look over the last video I made about ionic compounds before you watch the properties of ionic compounds today. It was really talking or taking you through how sodium, which is this solid, reacts with chlorine, which is, so the sodium that is solid reacts with chlorine, which is basically a gas, okay, it's a non-metallic gas, to give me the sodium chloride. Sodium chloride is a crystal, as you see, which is the table salt, okay? So how these react together to give me a completely different compound, which is the sodium chloride, okay, which really, this is one of the mystery of the chemical reactions, how electrons are moving from the sodium gained by the chlorine, and how this will result in ionic bonding. All of these will be explained in my last video, so please have a look over it. Today I will be more focusing on the properties of ionic compounds. And when I say ionic compounds, we all know it's made up of a attraction between the positive ions and the negative ions. Okay, let me give you the sodium chloride as an example, but it's not only one sodium ion and it's not only one chloride ion. It's a group. It's a lot of sodium ions and a lot of chloride ions that are held together by electrostatic attraction. What do I mean by electrostatic attraction? Is the attraction between the positive ion, as you see here, and the negative ions. This attraction is strong attraction between the two different ions. And because there are a lot of ions in the crystals, so I call it giant ionic lattice. Giant because it's big, ionic because it's made up of ionic bonds, and lattice because it is arranged in a regular structure. Okay? Now, for the best way to model these is the ball and stick model. If you look here, this model here, when they refer to sodium with the green balls, okay, chloride or chloride with the yellow balls, and then they're trying to join them together by sticks, as you see here. This is called the ball and stick model. This model is not really showing the reality that's between the positive and the negative. It's just for us to understand how it works, but actually in reality there are no gaps between the sodium and the positive and the negative ions. They're actually sticking together, all right? But this is the best model if you wanna show it to students in middle school, in high school, how to represent for them the ionic bonding. The ball and stick model would be easier for them to understand, okay? Now, after I explain the nature of the bond, which is, as I said, not a weak bond, it is actually a strong bond, what would you conclude about the properties of this giant ionic lattice? I would say, and also that's a common sense, that this kind of attraction is hard because it's basically an electrostatic attraction between positive and negative ions. That means if I want to melt this lattice, I would put a lot of energy, or I would need a lot of energy. I would need a lot of energy to separate these ions from one another, having said that the bond between them is really, really strong. So I would conclude that the boiling and the melting point for the ionic compounds is high, okay, which is one of the properties, or one of the main properties of ionic compounds. So the second point, other than having high melting and boiling point, is that they cannot conduct electricity when they're in the solid state. For the same reason, for typically the same reason. The negative and the positive ions, as you see here, are held strongly together, right? By the electrostatic attraction. When I say electrostatic attraction, guys, it just means the attraction between positive and negative ions. That's it. Okay? So they're held together by this ionic bond or by this strong electrostatic attraction. That means there are no free ions to move and conduct electricity. That means if I melt this ionic compound into the liquid state, we all know that the liquid state, the ions here are free to move, right? They're free to move. So they can conduct electricity in the liquid state, okay, or when they're molten. The same thing when they're dissolved. Look at that. When they're dissolved, the ions are surrounded by water from each direction. So also here the ions are free to move. And once I see a charged particle that is free to move, it can conduct electricity. So that's why the main properties of the ionic compound, they can conduct electricity when dissolved, and they can conduct electricity when they're molten, but they can't conduct electricity when they're solid. And this explains why if you get some table salt and then dissolve it in water, then connect it to your battery or to your voltmeter, you would find the reading, because obviously it can conduct electricity. While this will not happen if you just bring a solid piece of salt and connect it to your battery, the current will not pass. Okay? So basically, those were the properties of ionic compounds, which are quite self-explanatory. If you understand the nature of the ionic structure or the ionic bonding, you would easily conduct that. They have high melting and boiling point, they're solid, the ions are held in place, so the compound cannot conduct electricity when it's solid, but it can conduct electricity when it's molten or dissolved. Also, of course, one of the main properties of ionic compound that they are hard for the same reason. They're hard because of the giant ionic lattice, which is made of positive and negative ions held together in a regular lattice. That's why it is hard to break. Okay? Now, I'm gonna finish this with a question from the past paper. Really easy one. Just give me a minute. Yeah, it's here. Okay. So if I look here, that's the one of the past papers about ionic compound. So ionic compounds such as potassium sulfide, I answered the first question about the nature of the potassium sulfide in the previous video. So this has high melting point and conducts electricity when dissolved in water. Draw one line from each property to the explanation of this property. Why does it have a high melting point? Free electrons or electrons are free to move? There are no charged particles free to move? No, obviously. Ions are free to move? Obviously no. Weak intermolecular forces? No, because that's a high melting point. So bonds are weak. Of course, that doesn't give a reason. Bonds are strong. It has a high boiling point because bonds are strong. What kind of bond? What kind of bond? Ionic. Ionic bonds are strong, that is holding the positive and the negative ions together. Conduct electricity when molten. Why can they conduct electricity in molten? What I said is that electricity to be pass or to move through wires or through solutions, it needs a charged particle that is free to move, whether this charged particle is an electron or is an ion. So this leaves me between these two answers, and a lot of students, they mix up. They choose electrons. The entity that I have in the ionic compound is not electrons, it's ions. When I say sodium chloride, okay, this is not an electron, this is an ion, that's an ion. Okay, and the negative charge that is showing on this chlorine is really, or on this chloride, is really because there's an extra electron that has been taken from the sodium. But this is an ion, that's a positive ion, and this chloride is also a negative ion. These ions, when they are molten, they are free to move. So this is the correct answer. The ions are free to move because simply when they're molten, they're separated from one another, as I explained earlier. I hope this was a quick and short and common sense concepts for you to know today. Thank you so much. Have a great day.